Okay, hi everybody. I'm just going to do a quick example here of solving a quadratic. So let's say we've got x squared minus 14x minus 40. Now, first thing I want to do here, now it's set equal to 0. So the first thing I want to do here is I want to factor it. Because remember, when I write it as in terms of two factors multiplied together, a, b, let's say multiplied together, as soon as I know that the product of those two is equal to 0, I know that either a is equal to 0 or b is equal to 0. Okay? They could both be equal to 0, and that's going to give me that product. So that's what I'm looking for. I'm looking to factor this down here. Now, I might start up, sorry, doing something like this. And I'm going to break this down here. I know that the first two terms in those binomials have to multiply to get x squared. My last two have to have a product of negative 40 and add to negative 14. Now, I think the obvious choices here, whoops, I don't know why it's doing that. Whoa, sorry about that, would be 4 and 10. Okay, because there's my product of 40 and there's my sum of 14. But because my sum here is negative 14, they both have to be kind of negative here, or at least the larger one has to be negative. But the product here has to be negative 40. So one of them has to be negative, one of them has to be positive. So in order to have a negative sum, that means the larger one has to be the negative one. But if I try this, I'm going to get, if I expand this out now, I'm going to get x squared minus 10x plus 4x minus 40. I've got the minus 40, but that becomes negative 6x, which is not what the original expression was. So that actually doesn't work. So it turns out that factoring in this case isn't going to work. Now, or at least maybe I should say it like this. If I take a look at this and my first attempt to factor here doesn't work, what I should check here is my discriminant. Okay, my discriminant here. And sometimes we use the symbol delta to represent the discriminant here. So b is going to be negative 14 squared minus 4 times a, which is 1 here, and negative 40. And that's equal to my discriminant here. And when I put that all together, I'm going to get, what is it? I think I'm going to get 356. Now, that means that's good. Because it's positive, that means I'm going to get solutions. I'm going to get real solutions. Okay, I should probably write that up here. I'm going to get real solutions. Now, if I try to take the square root of that, I get an answer that is approximately 18.9. Now, because that is a fractional number, it's not a perfect square root. This means this is going to be not factorable. Okay, I'm not going to be able to easily just figure that out here. I can get factors. Don't get me wrong. When I say not factorable, I mean I'm not going to get these nice integer, this nice two binomials multiplied together with little integer values as the coefficient as the constant there. So what I have to do then is, therefore, I have to use the quadratic formula. Whoops. So I exhausted my efforts factoring. So here we go. So x is now going to equal, and it's going to be negative of negative 14 plus or minus the square root. And I've already figured out, remember the discriminant fits underneath that radical symbol here. And I've already figured that out. That's 356. And this will be all over 2 times a, which in this case is 1. So this is going to be 14 plus or minus the square root of 356 over 2. Now, I don't want to end right here because I want to see if I can do anything with 356. But it turns out I really can't. It's going to be 4 times 89 is 356. So I can take out that, I can take that 4. I've got two factors of 2 in there, so I can take out a factor of 2. I can simplify the radical in that form, but 89 is a prime. So that's as far as I'm going to be able to take that. Now, I can distribute the 2 to both of those terms. That is frequently a common mistake made there where the 2 does not get distributed to both terms, but I can do that. So 14 divided by 2 is 7, okay, plus or minus. And when I divide those 2's, I'm going to get 1 here, so it's going to be 7 plus or minus the square root of 89, okay? And that's the solution that we are looking for.